So in physics we have a number of laws and they can be understood from really basic principles. But at the end of the day they are taken from measurements.
The question is there anything beyond that? Because we know physics is incomplete.
And by looking ever and ever more precise, you hope to also find something that maybe you don't understand.
We are looking at vibrations of a molecule, of which you can predict the frequency at which it ticks.
You need to measure time. There you have the best hope to reach the highest accuracy.
It's one of the ways how you can test physics, by looking very precisely.
Atomic clocks can measure with 18 digits of precision.
So it would be really nice if we can actually dig deeper and find the really underlying physics of that sort.
If you want to prove that the theory is correct now at the even higher accuracy, then of course you have to provide highly accurate experiments.
The problem is that the simplest of atoms are the hardest to measure. It really gives me lots of joy to come up with a method to make it work after all. So that's why we want to isolate a single, very simple atom in a vacuum so that it's not influenced by anything else.
This one single atom that you're now manipulating exactly the way you want it. That's totally insane.
No external fields and no collisions or anything, then it will vibrate with a very specific frequency.
And we look at very simple molecules that are basically two particles that are connected by a spring. They vibrate, and we can actually make them vibrate more with the laser.
And we can use it as the pendulum of a clock. It's an oscillator that oscillates in a very predictable way. This gives us hints on where to look for, how to change the standard model to make it even better. We look at how they absorb light and which frequencies particularly.
One way is that you take a very precise laser that gives one color and you shine it on the atom and you see if it reacts. And then you tune the color a little bit until you find the exact color where it reacts.
And at some point you would stumble into something where the laws of physics give a false prediction.
If they don't agree, experiment and theory, then we can actually use this to find missing parts in our theory.
If it doesn't match, then of course the same game applies to what I am doing. Is there new physics?
Than what we have in our standard model.
And it so turns out that we are currently seeing such a big discrepancy.
The standard model is not finished. There are still numbers in there which come out of the blue. That's just a way of saying we don't understand them as of yet.
Nobody knows where this comes from. This is a number.
And that's a fundamental quantity that is basically used everywhere because it is one of the ingredients that goes into the theory.
But why this value is exactly like that, it's not explained.
If you would change all these numbers, these fundamental constants by just 1%, then we would not exist.
So it only starts to become interesting when you really can compare it with theory.
They should be the same if the laws of physics are correct. And we can actually do measurements that are more precise than the predictions of the laws of physics.
I go into the lab, I turn on my machine. I can make observations where I know no other human before has seen it, or maybe only a handful of people.
It's really trying to see if there's any more secrets behind the physics we know. And we know it is the case because of deviations we find in our own measurements. You think like, where does this come from?
You're working on a system that is understood so well, but looking for physics that is not understood at all with it.
If we do it well, then we can really study fundamental physics.